Welcome, ladies and gentlemen. So what I'd like to do is show you how to factor higher order polynomials using the difference of two squares. So basically the difference of two squares is, if I had a squared minus b squared, basically what we learn from our factoring practice is this can be factored down into a minus b times a plus b. Because basically my first two terms are multiplying to give me a squared. My last two terms are multiplying to give me b squared. And the minus and the addition, they multiply to give me the negative. And the middle terms, if you were to apply FOIL, are going to add to 0. They cancel out or sum to 0. So in these problems, though, we're not going to be dealing with any quadratics. Like a quick little example, like x squared minus 16 is x minus 4 times x plus 4. You can see that x squared is a squared term. So when we're looking for difference of two squares, we're looking for a term that is squared. We're looking for the first term squared and the last term squared, just like perfect square trinomials. But we're looking for the difference of two terms. So x squared is obviously a square term, x times x. And 16 is obviously a square term, 4 times 4. But since it's minus 16, we need negative 4 plus 4. And if we were to apply FOIL, our middle terms, obviously that gives you x squared. That gives you negative 16. This gives you negative 4x. And then this gives you positive 4x. That adds to 0. So you're just left with x squared minus 16. But with higher order polynomials, it sometimes becomes a little tricky to identify if it's a square term or not. So again, I just want to kind of remind you with like the power rule. I don't think I explained this last time. Remember, if you had a variable of a and then raised to the b power, that basically means x to the a times b. So, and what I want to do is I want to say, is this a square term and is this a square term? Well, in my last example, we are obviously see 16 is a squared number. That's 4 squared, or 4 times 4. Well, what about x to the fourth? Is that a square term? And yes, it is. We can rewrite it using our power rule as x squared squared minus 16. So if we're going to follow along the path that a squared minus b squared equals a minus b times a plus b, therefore, all I need to do is then identify what is my a and what is my b. So I basically have a squared and b squared. So in this case, what I want to do, I can rewrite this as 4 squared. What I can do is now identify that a is equal to x squared and b is equal to 4. Then I can just plug that into this into my formula, or formula for difference of two squares, and write x squared minus 4 times x squared plus 4. And ta-da, there we go. It has been factored. Moving on, you can see now I have a variable in the numerator, or in the first term and in the second, or I now have not just x to the fourth, but I have 9x to the fourth. But again, is 9 a squared number? Yes. So we want to make sure, can I rewrite 9x to the fourth as a term squared? And I can. I can rewrite this as 3x squared squared. Because if I was going to square 3x squared, that'd be 3x squared times 3x squared, which would give me 9x to the fourth. And then I can obviously write 25 squared, that's a squared term, as 5 squared. Now I can see that a is 3x squared and b is 5. So I can factor this as using difference of two squares as 3x minus 5 times 3x squared plus 5. Sorry, I meant to say squared. Okay? And then I can just do one more example here. Again, you can identify what my a and my b is going to be. And basically another way of kind of looking at this is I know this is a difference of two squares. So I have a minus and a plus. What two numbers give me minus and a plus? I know I see this is difference of two squares. What two numbers multiply to give me 64? Well, that has to be 8 and 8. What two numbers multiply to give me x to the fourth? They're exactly the same. That's x squared and x squared. And then what two numbers that are exactly the same multiply to give me 49? Well, that's going to be 7 and 7. So just another way to kind of look at it. Because the next couple examples aren't as easy as the top equations. Because what you can notice here is while I have x to the fourth here, those are squared. But the values I have in them are not squared. These are not squared terms. 12, I can't rewrite 12 as a number squared. It's not a square number. However, I do realize that I want to see, can I maybe factor out a common factor? And between 12 and 27, I realize that 3 is a common factor. So if I factor out 3, I'm left with 4x to the fourth minus 9. So now I see that is 4 a squared number? Yes. Is x to the fourth a squared term? Yes. Is 9 a squared term? Yes. So therefore, I can now rewrite this as 2x squared minus 3 times 2x squared plus 3. In the next example here, you can see, again, this one I have a variable in the first term and in the last term, but that's OK. Again, you can just kind of look at this and say what to rewrite this as a product squared, so that's x squared squared. Rewrite this as a product squared, that's 6x squared. So therefore, you could say x squared is my a and 6x is my b. So it'd be x squared minus 6x times x squared plus 6x. All right, in this example, not only do I not have numbers that are squared numbers, 32 is not a square number, nor is 200, nor is 5, nor is 3. However, kind of going back to my thinking over here, if I can find terms that they have in common, let's look to factor them out to see if I can still use the difference of two squares. And I notice they both share a 2 I can divide out, as well as, and you could possibly say a 4, but if I factor out a 4, like let's just say I factor out a 4 here, then, or they have a 4 in common, and possibly even a higher, but they have a 4 in common and an x cubed. So if I factor out a 4x cubed, then I'd be left with 8x squared 20 minus 40. Well, while that helped me out as far as factoring them out, that didn't really do much for me here because 8 and 40 are not square terms. So that didn't really help me out. But what I do kind of realize is if I factor out a 2 instead, if I factor out an x cubed, a 2x cubed, what that's going to leave me with is a 16 x squared minus 100. And then 16 is a square number, x squared is a square term, and 100 is a square term. So now I can rewrite this as 2x cubed times 4x minus 10 and 4x plus 10. Now, obviously, I could factor out further. I could factor out a 2 from those as well. And therefore, when I factored out a 2, that would give me that 4, which was my original product, which actually 2, and that would give me 4, so 8. 8 would have been my highest, 80, 160. Yep, so 8 would have been my highest factor because you factor out a 2 out of both of those and multiply. But either way, if you recognize your perfect square numbers, you can just factor out a term that's going to give you perfect squares and factor it that way. So there you go, ladies and gentlemen. That is how you factor using the difference of two squares for higher order polynomials. Thanks.